Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 3 from lesson 9-2 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to use factoring to solve a real-world problem. So in this problem, it says that there's a museum vault that has an outer steel wall with a uniform width of x. The area of the museum vault ceiling and the outer steel wall is 1,664 feet squared. So they're saying all of this area. What is the width of the outer steel wall? So we're looking for that width. All right. So the first thing is recognizing that this is a rectangle. And so what do we know about rectangles? Well, we know that their area is equal to their length times their width. So if I can get an expression that describes the length and the width, I can use this area equation to help me to determine that width of the wall, okay? Now this wall, it's going all the way around, right? So this distance here is also x, this distance here is also x, and this distance here is also x. So while they're giving us the length and width inside of the room, you also have to add x for each side. So on the 20 feet, I would need to add x here and here, so I would add 2x to the 20 feet. And then the same thing for the 40 feet, all right? So my length in this case is actually 20 plus 2x. And my width is actually 40 plus 2x. And so I'm going to plug those into my area equation. Actually, I want to put the x's first, I think. For simplicity's sake. So I'm going to call it 2x plus 20 and 2x plus 40. The reason why is when we factor, we're used to having the x's here in the front. So now the other thing is the area. And so our area is 1664. So I could actually plug that in where the a is as well. Alrighty, so now the only thing left in this equation that's unknown, or the only variable, is x. So theoretically, I should be able to multiply all this stuff out and then get a value for x. Alright, so the first thing I'm going to do is distribute this stuff. To do that, I'm going to use the box method. So I have 2x plus 20 and 2x plus 40. So here in the top left, I have 2x times 2x, which is 4x squared. 2x times 20 is 40x. 40 times 2x is 80x. And 40 times 20, what is 40 times 20? I don't know. Just make sure you have a calculator handy. I think it's 800, but it's morning for me, so there we go. Alrighty. So my equation, I have 1664 equals all this stuff that I got from my box, right? So I have a 4x squared, and then 80x and 40x together makes 120x, and then plus 800. Now when we have an equation that's written in standard form, we need to go ahead and move this over to the other side as well so that it's set equal to 0. Alright, so I'm subtracting 1664 from each side. So now my equation is at 0 equals 4x squared plus 120x minus 864. Now, these numbers are kind of big, right? Like, in this situation, I would factor by grouping, so I'd need to multiply together 4 times 864, and try to find what subtracts to make 120. That's a bit much. So what I'm checking out is I'm looking to see if I could divide 4 out of each of these, and I actually can. All right, so that's what I'm doing to make my numbers a little bit smaller and more manageable. You won't always be able to do it, but pretty regularly you will. So the numbers now aren't quite so bad. They're still big, but they're not quite as big. Okay, so this is actually factorable using the double bubble method now that there's a 1 in front of the x squared. Alright, so I filled in my x and my x. My first sign is a plus and it just falls down. Alright, now this second sign says that I have to have opposite signs down here, so this is also going to be a minus. Alright, so now I need to find the factors of 216 that subtract to make 30. I don't know what that is, so I'm just going to very systematically go through it. So I know 216 and 1, which is 215, which is not what I'm looking for. 216 is divisible by 2. It's 108. I don't know if it's divisible by 3. Let's figure that out. So 216 divided by 3 is 72. That gives me 69 difference. Now, when I divided by 2, I got 108. That means that that's still even, so it's divisible by another 2. So 4 is definitely able to go in here. It is 54. 216 doesn't end in 5 or 0, so it's not divisible by 5. But it is divisible by 2 and 3, which means it's divisible by 6. So 216 divided by 6 is 36. And 36 minus 6 is 30. So that's my set that I need here. Okay. So now that we have factored it, now let's go ahead and let's use that zero product property. And we're going to set each of these factors equal to 0 to get some possible solutions. So I have x plus 30 equals 0 and x minus 6 equals 0. So here on the left I would subtract 30 to get x alone. And I get that x equals negative 30. And on the right hand side I would add 6 to get the x alone. And that gives me x equals 6. So between these two solutions, we have to think about it in the context of this problem. So the x is the width of a wall. It's like I'm taking a ruler and figuring out how long that wall is, right? I can't measure with a ruler and get a negative value. So it cannot be negative. So our only possible answer is 6. And since this is a word problem, I'm going to go ahead and answer this with a word solution. So the steel wall would have to be 6 feet wide, I guess would be a way to say it, in order to match these dimensions. Got to make that text really tiny because this was a long problem, wasn't it? So what I'm going to do, because that one was so long, is I'm going to try to get myself a little more room up here. Okay. So for the triad, it says a picture inside of a frame has an area of 375 centimeters squared. So this is just in here is a 375. So notice on the last problem they gave us the outside area. Now they're giving us the inside area. Okay? And they want us to find the width of the frame. So I'm still using that area formula, that the area equals the length times the width. But what I'm going to do now is when I decide my length and my width, I'm taking this overall length and I'm subtracting the x's to get the inside area, okay? So my length in this case would be 30 minus 2x. So I'm going to call it negative 2x plus 30, just to get my x's first. And then my width is 20 minus 2x. So I'm going to call it negative 2x plus 20. All right, now those two things equals this area, that 375. So I'm actually going to plug in the 375. All right. So now just like last time, I'm going to go ahead and use the box method to multiply those together. So negative 2x plus 30, negative 2x plus 20. So in the top left, negative 2x times negative 2x is a 4x squared. Negative 2x times 30 is negative 60x. Negative 2x times 20 is negative 40x. And 20 times 30 is 600. So when I'm writing this box out, remember I'm collecting the like term of the 40 and the 60x. All right, so now we need to get it in standard form, so we need to set it equal to 0. So I'm subtracting 375 from each side so that my equation will be equal to 0, because then when we factor, we could deal with our zero product property. I don't know what 600 minus 375 is. It's 225. Okay. Now last time I was able to use the trick of dividing by 4. I can't do that here because 225 is not divisible by 4, which is a big bummer. So what that means is that I have to do factoring by grouping. So remember, with factoring by grouping, I split my b term into two terms that add up to that b value. And so now I need to figure out what it would be. So I'm looking for the factors of 4 times 225, which is 900. And because the second sign is a plus, they need to add to make 100. Big yikes. Well, I know 9 times 100, right? But that's 109. It's 900 divisible by 8? No. Let's see, is 900 divisible by 7? Nope. 900 is divisible by 6, it's 150. But see how my numbers are getting bigger as I'm coming back this way? So I need to keep looking for bigger numbers that like bigger numbers that will work here. Okay, so not between 1 and 9. So let's try 10. So at 10, I get 90, and that's 100. Okay, so I'm going to change this minus 100x to saying minus 10x minus 90x. All right. So my next step is to put them in parentheses. Now it's important when we put them in parentheses that there's a plus between the parentheses. So notice that I kind of scooted that minus over and then just squeezed a little plus in there, okay? And now we're going to factor out the greatest common factor for each set of parentheses. Alright, so between 4x squared and 10x, I see a 2 and an x. And when I divide that out, I get 2x minus 5. And so then when I'm looking at this one, I see that my signs are backwards. So whatever my GCF is that I factor out, it'll be a negative. And I want to be left, right, because these still need to match. So I want to be left with 2x minus 5. And so since I don't know what that GCF is, I'm going to take 90 and divide it by 2. I get 45. And to verify, I'm going to take 225 and divide it by 5, and I still get 45. So that's how I know that 45 is my GCF here, even though those are such big numbers, because my blue parentheses here have to match. All right, so then to finish factoring, I'm going to go ahead and take all the stuff that I factored out, my GCFs, and they go in one set of parentheses. And that set of parentheses is multiplied by the matching set. So now that it's factored, now I can use the zero product property to figure out these two values. So I'm taking the two sets of parentheses that are set to equal to 0, and I'm setting them equal to 0 independently. Okay, so see the red one and the blue one? So now we're just going to solve. So first I need to add 45 to each side. So here I have 2x equals 45, and then if I divide by 2, I get that x equals 22.5. But that doesn't work, right? If this width is 20, this x can't be 22.5. It's bigger than its width. So this is not a possible solution. Alright, so now let's try the blue one and see if the blue one works out. So I'm going to go ahead and add the 5 over. So I get 2x equals 5. And then if I divide by the 2, I get that x equals 2.5. And that 2.5 centimeters is a lot more reasonable, right? There's actually enough room to fit it. So to answer my word problem with my word answer, the width of the frame would need to be 2.5 centimeters to match the given dimensions. So there we have it, guys. That's how we use factoring to solve a real-world problem. Until next time.